So now let's run through a few examples of implicit differentiation to see things we should look out for. Okay, find dy dx given this expression here, this equation. All right, so again, I'm just going to have x cubed minus xy plus y squared equals 4, and I'm going to take the derivative with respect to x of both sides. Okay, so on the left-hand side here, when I take the derivative of x cubed, that's 3x squared minus. Okay, now I have to be careful because xy, remember y is a function of x, so this is actually a product. So I'm going to put some brackets here just to make sure I separate it and don't get the signs messed up from this minus in front. So when I take the derivative of xy, I have basically my first function x and my second function y. So the derivative of x is 1 times y as it is plus x as it is, and the derivative of y would be 1 dy dx. Okay, so this is the entire result of the product rule applied to xy. Then I get plus, and I have to handle this y squared, but that's 2y dy dx because it's a y term equals 0. Okay, so there's all the derivative taking, and now basically I just have to do my usual isolate the dy dx to solve for it. Alright, so 3x squared, now I get minus y when I distribute, minus x dy dx plus 2y dy dx equals 0. So I'll leave the dy dx terms over here. So minus x dy dx plus 2y dy dx, and then I'll move the other non-dy dx terms to the other side. So I would get minus 3x squared plus y. Alright, so now I'll just factor out dy dx from the left. So negative x plus 2y equals negative 3x squared plus y, and then finally just divide this term to the other side. So minus 3x squared plus y over minus x plus 2y, and there's my derivative. Okay, again, it does have y's in it, both as x's and y's, but that's natural seeing as we started with it implicitly defined. Alright, let's try another example. Find dy dx given x e to the y minus 10x plus 3y equals 0. Okay, x e to the y minus 10x plus 3y equals 0. Alright, take the derivative of both sides with respect to x. Alright, on the left-hand side, again, I have to be careful because when I see this, that again is a product. I have the first function x and the second function e to the y. Alright, so when I go and do that, so when I go and do this product, the derivative of x is, with respect to x is 1 times the second part e to the y as it is, plus the first thing as it is, and then the derivative e to the y with respect to x. But it's e to the something, so it gives me back e to the y. Then I go and take the derivative of y, but that's just dy dx. Again, that's all the result of the product right there. So then I move on to the minus 10x. With respect to x, that's just minus 10. And then plus 3y plus 3, derivative of y is 1 dy dx equals derivative of 0 is 0. And there we go. Once again, I have to just isolate the dy dx term so that I can solve for it. Alright, so I'll leave x e to the y dy dx plus 3 dy dx. On the other side, I'll have I have the 10 to move over, so I add 10 and subtract e to the y. Okay, and then on the left, I'll factor out dy dx. X e to the y plus 3 equals 10 minus e to the y. And solving for dy dx, 10 minus e to the y over x e to the y plus 3. There we go. Okay, how about another? Find dy dx given sine 3x plus 2 cosine 2y equals 1. Okay, still, sine 3x plus 2 cosine 2y equals 1. Derivative of both sides with respect to x. Alright, so on the left here, d dx of sine 3x. Well, that's sine of something, so I get cosine 3x, and then the chain rule says take the derivative of 3x, which gives me 3, I'll put it in front, plus 2. Derivative cosine 2y, well that's cosine something, so I'll change this to minus sine 2y, but then I go and take the derivative of 2y, and I'm actually going to get a 2 dy dx. Okay, so I have all of this equals 0. So let me clean that up a bit. 3 cosine 3x minus 4 sine 2y dy dx equals 0. And then finally, just solve for dy dx. So minus 4 sine 2y dy dx equals minus 3 cosine 3x. Alright, when I divide over, the negatives will cancel and I'll be left with 3 cosine 3x over 4 sine 2y. There we are.